Hello everybody, it is time to take a look at 8-2, which is the section that introduces trigonometry to us. So for this first question, Jacinta's teacher asks her to find the tangent of angle y. What is her error? So for her, when she takes the tangent of angle y, she uses xy over xz. So she actually used the side adjacent to y over the side opposite to y. But we know that tangent is opposite over adjacent. So it should be tangent of y is equal to opposite 2 over adjacent side 6, which is actually 1/3 rather than 3. Number 17, if the sine of b is 1/2 in the triangle shown, what is an expression for AB? This is weird. All right, but we know the equation that has the sine of 1/2, or the type of triangle that has a sine of 1/2. So if I'm starting from angle B, any time that the sine is 1/2, that means that opposite over hypotenuse is 1/2. So we just say 3x divided by what is going to, 3x is half of what? Because opposite over hypotenuse has to be 1/2. 3x is half of 6x. So that side has to be 6x in order for opposite over hypotenuse to be equal to 1/2. Well, we know what kind of triangle this is because any kind of triangle where the hypotenuse is twice the length of the short leg happens to be a 30, 60, 90 triangle. We'll write that. This is a 30, 60, 90 triangle. And since this is a 30, 60, 90 triangle, we know that the third side is going to be x root 3. And since our short side is 3x and not x, our third side is 3x root 3. And that'll be the expression for side AB. Number 18, every tread of a staircase is 8 inches deep and every riser is 6 inches high. How would you find the angle the staircase makes with the floor? Well, if every angle is the same, that means that every angle makes the same, every step has the same angle with the floor. So we can just find the angle of one step, maybe the bottom step with the floor. So we know that this bottom step is 8 inches deep, the riser is 6 inches high, and we need to find the angle that the step makes with the floor. I guess I've drawn this backwards. Let me draw a better step to use. It's easier in this case for us to think about the step from the floor and not just the step itself. So there's the floor and there's the angle. So the step is 8 inches deep and 6 inches high. And we want to find, let me do this in a different color. We want to find this angle right here. Maybe I can call it angle X. So I know if I'm standing on angle X, I know the opposite and I know the adjacent. So I know that the tangent of angle X is equal to opposite over adjacent is equal to 6 over 8. And if I need to go backwards and just find X, I can get rid of the tangent by doing inverse tangent. Because inverse tangent of the tangent of x is going to be equal to inverse tangent of 6 over 8. So I'm just taking the inverse tangent of both sides, which is going to give me x equals, and then I would go on my calculator and find the inverse tangent of 6 over 8, and that is 36.87 degrees. And that's my answer. So that is the angle of x. Number 20, why are the sine and cosine ratios of x never greater than 1? Use the triangle below to explain your reasoning. So the main reason for this is because in a right triangle, the hypotenuse is always the longest side. So if we're standing on angle x and we're doing the sine, or the opposite over the hypotenuse, we're going to be doing a smaller number divided by a larger number. If we're doing the cosine, we're going to stand here. We're going to be doing a smaller number b divided by a larger number c. So either way, we're doing a smaller number divided out by a larger number because no sides can ever be longer than the hypotenuse. So we can say the legs of the triangle A and B, the legs of the triangle A and B can never be longer than the hypotenuse C. Hypotenuse C. There we go. Here we're going to write each ratio. So if we're standing on x, sine is opposite over hypotenuse, or A over C. If we're standing on x, cosine is adjacent over hypotenuse, or B over C. And tangent is opposite over adjacent, or A over B. So easy stuff there. And then for 24 over 29, we want to find each value. And luckily for us, we can know all three side lengths. So for example, the sine of x would make us stand on x and use opposite over hypotenuse. So that would be 2 divided by 2 root 17. So 2 divided by 2 root 17, that simplifies to 1 over the square root of 17. But we can't leave it like that. We want exact answers. We're going to rationalize by multiplying by root 17 over root 17. And that is finally going to give us 1 square root of 17 over whole number 17, since the square root of 17 times the square root of 17 is 17 units. Number 25, the cosine of x. So the cosine of x, if we're standing on x, we'll do adjacent over hypotenuse, 8 over 2 root 17, which of course gives us 4 over the square root of 17. Once again, we have to rationalize the denominator by multiplying by root 17 over itself, and that is going to give us 4 root 17 over 17, similar to the last one. Number 26, tangent of x. Whoops, come on. Tangent of x is going to be opposite over adjacent. So in this case, if we're standing on x, opposite is 2, adjacent is 8. 2 over 8 simplifies to 1/4. Number 27, the sine of y. So the sine of y is going to be us standing on y and doing opposite over hypotenuse. 8 over 2 root 17 is something I've already done, though. So the sine of y is going to be 4 root 17 over 17, the same as the cosine of x. So 4 root 17 over 17. And that pattern is going to continue to the cosine of y, because the cosine of y, if we're standing on y and we're doing adjacent over hypotenuse, it's going to be 2 over 2 root 17, which we already did over here for sine of x. So root 17 over 17 is going to be the cosine of y. And then finally, the tangent of y. If I'm standing on y, doing opposite over adjacent gives me 8 over 2, which gives me 4. All right, next, for 30, 31, 32, 33, 34, 35, these are all straight from your notes. We had an example where we found all of these out using our special right triangles. So we can just copy them into here. The sine of 30 is 1/2. Cosine of 60 is 1/2. Sine of 45 is root 2 over 2. Tangent of 45 is 1. Cosine of 30 is root 3 over 2. And tangent of 60 is the square root of 3, just copying those down from before. Number 36, write an expression for cosine of 68 using sine. We learned that we can write the expression using the complement of the angle that helps it add up to 90. So cosine of 68 would be the sine of the complement, or 22 degrees. 37, same idea. The sine of 44 is going to be the cosine of its complement, or the cosine of 46. Then 38 and 39, find each length. So to find the length of AC, I'm going to use trigonometry here, because AC is right here. It's the opposite side. Well, I guess it doesn't matter whether we think of the opposite or the adjacent. But when I look at this side, I like to think of maybe I'm standing on angle B. And if I stand on angle B, then opposite over adjacent is tangent. And I know the adjacent side. So I can make the equation, the tangent of 31 degrees is equal to opposite, x, I don't know that side, over adjacent, 9. Then I can just multiply both sides by 9. 9 tangent of 31 is just a number, and it's a number that's equal to the length of side x. So if I take my calculator and I plug in 9 tangent of 31, I get 5.4 equals x. For BC, if I wanted to find this one out, there are a few ways to do it. If I still imagine myself standing on B, BC is going to be the hypotenuse. When I look for what I know in my triangle, I know the adjacent side to be. So I think, what is adjacent over hypotenuse? That's cosine. So I can write the equation, the cosine of 31 equals adjacent, 9, over the hypotenuse y. I don't know that hypotenuse yet. So then I can solve this equation. I can multiply both sides by y to get y cosine of 31 equals 9. Then I want to get y on its own. So then I'm going to divide both sides by the cosine of 31. That tells me that y is equal to 9 over the cosine of 31, which is equal to approximately 10.5. And that would be the value of BC. All right. We can also go backwards. We can use trigonometry to find angle measures. So when we're using trigonometry to find angle measures, we can say, all right, for 40, the measure of angle B. If I'm standing at angle B, I know the opposite and I know the adjacent. So I can state that the tangent of angle B is equal to, I don't want to use a lowercase b there. I'll use a capital B, even though that's not really how I would normally write. So the tangent of angle B is opposite over adjacent, 3 over 4. And so in order to find B on its own, I need to undo the tangent. So to undo the tangent, I would take the inverse tangent of both sides. The inverse tangent of the tangent of B is just B. The inverse tangent of 3 over 4 is something that I need to use my calculator for. But my calculator is really good at it, so I just plug that into my calculator, and then I find that 36.87 equals angle B. I guess I don't need both of those on there. And I can be not lazy, we're going to say efficient, and we're going to use that angle measure in order to find the measure of angle C, because I know this is a right triangle. So I know if I do 90 minus 36.87, that's going to give me C. So 51.13 is C. I could use trigonometry for that, but why? I don't need to. Number 42 and 43. So same ideas here. I'm looking for the measure of angle K. If I'm standing on angle K, I know my opposite and I know my hypotenuse. So I know the things that I need to find the sine of angle K. So I'm going to say the sine of angle K is equal to opposite 5 over hypotenuse 9. Then I need to find K on its own. So I'm going to find the inverse sine of both sides. The inverse sine of the sine of K is just K. The inverse sine of 5 over 9 is something I need to use my calculator for. But when I plug it into my calculator, I find that K is equal to around 33.75 degrees. And just like last time, once I find k, I'm able to find L by just doing 90 minus that to find the complement. So 90 minus 33.75 is going to give me 56.25, and that is equal to angle L. There we go. Next, a coach draws up the play, so a quarterback throws a football at the same time as a receiver runs straight down the field. Suppose the quarterback throws the football at a speed of 20 feet per second. So throwing at a speed of 20 feet per second. And the receiver is running towards that ball and away from the quarterback at a rate of 12 feet per second. At what angle x to the horizontal line must the quarterback throw the football in order for the receiver to catch it? Now, in this question, there is some distractor information because it says the quarterback and the receiver are standing 75 feet apart. However, 75 feet is not the same kind of unit as 12 feet per second and 20 feet per second. So we can't use that 75 feet in our trigonometry here. We just have to use the 12 and the 20 since they are having their measurements in compatible units. Lucky for us, we have enough information because if we stand on x, we have the opposite and hypotenuse in the same type of units. So we can use sine to solve this. The sine of angle x is equal to opposite 12 over hypotenuse 20. I'm going to use the inverse sine to get x on its own. So the inverse sine of the sine is x. The inverse sine of 12 over 20 is something my calculator can do. And it tells me that x is equal to 36.87 degrees from the horizontal. There we go. 47, match each expression to a trigonometric ratio. So if we look at this triangle right here, I noticed something about it. Because I know if I used the Pythagorean theorem, this would be a 3, 4, 5 right triangle. That's what we call a Pythagorean triple. It's something we can memorize. And I can also find that ABC is a 5, 12 blank, which is another Pythagorean triple. If I use the Pythagorean theorem here, 5 squared plus 12 squared would give me 13 squared. So 5, 12, 13 is another Pythagorean triple. So the cosine of angle ACD is, if I'm standing right here, adjacent over hypotenuse is 3/5 or C. The tangent of angle ABC, here's my angle, opposite over adjacent is 5 over 12 or D. The sine of angle BAC, so that's this angle right here, sine is opposite over hypotenuse is 12 over 13, that's A. And then the cosine of angle CAD. So CAD is this angle right here. Cosine is adjacent over hypotenuse. That's 4/5 or B. And then finally, what is the value of the cosine of x? So I see that this happens to be an isosceles triangle. I don't know that it's an isosceles right triangle, but I do know that if I make the bisector of an isosceles triangle, it ends up being the perpendicular bisector, which does create a right angle. And if I'm standing on x, half of 16 here, that's 8, that's this side. And then the hypotenuse is 12. So I have the adjacent side and the hypotenuse. So I can say that the cosine of x is equal to adjacent 8 over hypotenuse 12. Notice it didn't ask for the measure of angle x, it just asked for the cosine of x. 8 over 12 simplifies to 2 over 3, so D is my answer. All right, if you've got any questions on this section, do not hesitate to ask. It's really important that you understand the basics of trigonometry before we get any further. All right, so go ahead and live with that here, and I will see you tomorrow.